Watch Mr. Wizard. Now, Mr. Wizard's not his real name, but that's what all the kids in the neighborhood call him, because he shows them the magic and mystery of science in everyday living. Buzz, one of the kids in the neighborhood, is coming in the door right now. So let's join him and watch Mr. Wizard.
Hi, Mr. Wizard.
Hi, Buzz.
What you doing?
Well, what does that look like to you?
See, a volcano.
That's right, that's a volcano. Right now it's erupting.
Gee.
Really goes on, doesn't it? And also makes things that makes me sneeze, I think. Excuse me. Well, you see, what you and I are going to talk about today is the world under our feet.
In your nose.
Getting in your nose, too, huh? And at one time, the earth that we walk on was once all molten liquid. And as it began to cool, a crust formed on the outside and got deeper and deeper, but inside the earth it's still very hot. And when some of that heat and molten material goes up through the earth, it forms a volcano. Now, there are still some volcanoes around the world in various places. Do you know where they are? Here's a map. See if you can find some.
I only know a few of them. See, there's one in Japan.
One in Japan, that's right, Fujiyama.
Mm-hmm. And then there's one in the Hawaiian Islands.
That's right, and there's some others in the South Pacific. In fact, you remember a little while ago an island blew up?
Oh, yeah.
Disappeared? That was because of a volcano, yeah. How about in our part of the world?
Mexico.
That's right, there are several in Mexico. Over in Europe?
I know there's some over here, but I don't know.
That's right, over here near Naples is one called Vesuvius.
Yeah, wasn't that the one that buried the city of Pompeii?
That's right, there's also some in Sicily. And, you know, our Rocky Mountains and the Alps and the Himalayas over here probably at some time had volcanoes in them also. So you see some of that heat that was in the center of the earth is still bubbling out and forming a volcano. Now, let's take a look at what happens when we have a volcano. I've got a new one. We're going to make another volcano over here. This time I'm going to have you set it off.
That's big.
Okay? And in order to do that, you put an eyedropper full of this liquid right on the top.
Whole?
Yeah, whole eyedropper full. It's dormant. Nobody suspects that there might be a possibility that the mountain will erupt. Just to help it along, put more liquid on it. It begins to smoke.
People start looking up.
Mm-hmm. They start now moving away.
Start to run.
There she goes.
There she goes. And they run like mad.
They sure do.
And they start to be buried.
Now notice this fine ash that's rolling down the side of the mountain. That's the same sort of ash that buried the town of Pompeii. Sometimes when water gets into the volcano, for instance, if there's a passageway underneath the ground from the ocean and water gets in there, and the lava gets mixed with water, it forms steam and little tiny bubbles form in the lava, and when it is blown out of the mountain, it rolls down in this form, also goes into the air in this form, and sometimes lands in the water and looks like this. See the little holes?
Oh, yeah.
Well, this is a form of material that comes from the mountain that is known as igneous rock. All rock that is formed by fire is called igneous. That's one of the words I want you to remember.
Formed by fire, igneous.
Igneous. You going to sneeze too?
Almost.
Well, what do you expect being here near an erupting volcano? That's what the word means. Fire formed. Igneous rock. This is one form right here. The specific name of this is pumice. In fact, because it has so many little holes on it, even though it is rock, here, drop it in that glass of water. See that?
Floats.
It floats, that's right. And would actually float in the ocean. Now, when they find pumice like this, they can very often grind it up into a fine powder like this. Here, put some of that between your fingers. Feel how very fine it is?
Yeah.
At the same time, you feel it has a grittiness.
Hard.
Well, they use that for polishing. Sometimes they form it into a stone, and it's called a pumice stone. That's one kind of igneous rock. Now, this time, you keep an eye on that volcano, because this time lava is going to come out.
Lava?
In fact, watch. See, while it's bubbling away here, not only pumice is coming out of it, but this time real lava. See it? Rolling down the side of the mountain. I'm helping it along just a little bit. Now, that form of rock, when it comes out, this is igneous also, right? Because it was formed under fire, or by fire. It rolls down the side of the mountain and begins to cool. And would look like this, for instance. See, there are various types.
I thought lava was black and hardened like cinders.
Well, the top surface of it, you see, that would be exposed to the air with so much heat would oxidize, and so would look more like cinders. But down below, where it's just plain hot and melted, when it cools, it finally could form something like this. Some of the lava, when it cools, is black. In fact, you recognize this?
It's granite.
And granite is igneous rock. In other words, formed by fire and laid down on a layer sometime. Well, I have a special little landscape over here. See, here's my little landscape, and we're going to investigate the various kinds of rock. Here's a mountain over here with, we might say, a big piece of granite, so you know that what is this black sort of stuff?
That's igneous rock.
Igneous rock, formed with fire. You see how it runs all the way over? There's another piece over here. So let's put a little sign up here, so we'll remember that this is igneous, formed from fire. Well, now, something happens to this igneous rock. We don't have igneous rock all over the place.
No.
Things begin to tear it apart. Well, let's see if we can find out what it is that tears this igneous rock apart. Now, you see this lava? Here it is down here, beginning to cool, see? Mm-hmm. This lava right down here would have bumps and holes in it, just like this has, see? Mm-hmm. And water could flow in there, couldn't it? And more lava could cover it, perhaps, and they'd have little pockets and cracks all full of water. All right, now, what if the temperature changed and it got very cold and the water could freeze? Strange things would happen. In fact, here's a very cold liquid over here. Let us pretend that this is igneous rock that has water in it. And let us get it nice and cold by putting it in this special bath.
Is that, liquid oxygen?
No, in this case, using dry ice, or solid carbon dioxide, and acetone to get it very cold. Well, let's also pretend that this bottle was made of igneous rock. Inside is water, cap on the top. If we put this igneous rock in and get it very cold, what do you suppose is going to happen to it?
I know.
What?
It's going to crack.
You think so? Well, keep an eye on it. Getting colder and colder, gradually forming into ice. Did you hear a crack?
Yep.
I did. I don't know whether that was a little bottle.
Yeah, it cracked a
began
little
to form
bit.
cracks. Yeah, the ice is holding it together. There, you see the cracks forming into it? And gradually, as it got colder and colder, it could pry the igneous rock apart. There's one way of going over there, too. In fact, let's take a look at our... see if there are any cracks in that yet. Let's leave that in there for a while and let it get nice and cold. Well, you can see how that crack would form. And get wider and wider as the ice began to, push on the sides and begin to break that igneous rock up into pieces. That's one way that it's broken up. Then what about when it was very hot, either from the heat of the earth or the sun beating down on it? If it were solid material, something like glass, and you heated it up, and it heated up unevenly, what would happen to it?
Well, it'd break.
Sure, it would break.
Oh, yeah, I know that. I've taken a glass and get it real hot, and then accidentally it gets real cold.
Breaks. Something like this, huh? In fact, see the stove over here? Let's pretend that that's the heat on the inside of the earth, and here I have some glass, which would be the igneous rock, and which had cooled, and now when it was heated up again, well, all kinds of things could happen, right? Now, this same sort of thing happens to igneous rock to help break it up into various pieces. Bam! Really went, didn't it? Didn't need to turn the other one on. In fact, let's push this one over, because at the same time as it was forced apart like that with heating unevenly, if it should also rain or water should fall on it, it's not hot enough yet. Because sometimes when you put water on it, not only does it crack into great big pieces, but it also cracks into little tiny pieces.
Not quite hot enough.
Not quite hot enough. You know what? Every time I put the water on there, it cools it off, right? And keeps it at what? 212 degrees. Because that's the temperature at which water boils. There we go. Now, let's take a look at that piece. There, do you see? Whoop. See this little piece right here? Oh, it's all cracked up into little, tiny little slivers. Well, that same sort of thing could happen to the rock. Well, that's another way that igneous rock is broken up. Besides, ice also changes in heat. Now, can you think of any other method that igneous rock might be broken up?
Wind.
Wind, especially when it carries little pieces of sand.
Yeah, like a sandstorm.
Like a sandstorm could go by and knock off pieces. How about another method?
Rain. It could wash it away.
That's right, it could wash it away. And when you combine all those various methods, gradually you're going to tear the igneous rock down, and some strange things happen to it. Come on over here, I'll show you. You're going to be the rainstorm, the rainmaker, Mr. Johnson, rainmaker. I'm going to be heat and ice and wind and rain and wear this rock away. And you pour the water over it here, so it would be the same as when it rains on the mountain when all these things are happening. See how the various types of igneous rock would be worn away into little tiny pieces and carried by the water. Notice down there we have a lake. Be careful you don't have it rain too much so our lake overflows the shores, huh? Okay, that's enough. Now, what's going to happen when all this material gets down there to the lake? Let's take a look. See what happens?
Gee, all the sand and all the rock and pebbles and stuff, they all went to the bottom and made a layer.
And they formed a layer. And adults would call this a sediment. Have you ever heard that word? Sediment, a layer on the bottom of something.
I think so.
Well, when there's enough weight of water pushing down on it, it is no longer individual pieces, but it's so much weight it pushes them together and forms a rock that might look something like that. Take a look at that.
Oh, yeah, you can see all the pebbles and all the sand, and it's all forced together to a rock.
And now this is no longer igneous rock, but it's called sedimentary.
Sedimentary.
Sure, because it was sediment and now formed into a rock. So let's go up and take a look at our landscape over here. See, here was our igneous that was worn away and formed a layer down here of sedimentary. And you know when you see sedimentary rock like this that at one time it was under a lake or an ocean. So let's put our sign here, sedimentary, like that. Now, what happens when some of this sedimentary has enough heat and pressure put on it? All kinds of strange things. We get a new kind of rock. Back here. Let us pretend that this is a mixture of sedimentary rock. I'm going to put heat and pressure on it with this, a nice hot iron. Watch what happens. Now, as this begins to cool off, remember we had heat and pressure on it. As it begins to cool off, it now forms a new kind of rock called metamorphic. And that comes from the Greek. Meta meaning change and morphic meaning form.
Metamorphic.
A rock that has changed form. And when this cooled, you see, we would no longer have little individual bits of wax, but a whole thing bound now into a new form called metamorphic. And I've got some samples of that over here. Oh, by the way, another very interesting aspect of rock that didn't come from igneous. Remember, that was the fire type, right? Yeah. You see, let's take a look at our ocean here. In this ocean were all kinds of little animals and plants. And they took calcium out of the water and used it to make skeletons and shells like this. Okay? Calcium carbonate they changed it to. And as they died, they fell down to the bottom and formed a layer 2.
They were heavier.
They were heavier. Until pretty soon there was a lot of pressure put on them also with the weight of the water, and they formed a kind of sedimentary rock also.
You mean they were forced down so hard that they bound together to make a rock?
Right, they make a rock. Now, scientists can check the presence of calcium carbonate in a shell by putting some acid on it. So you take that eyedropper and put just a drop of the acid on that shell. See how it bubbles up?
Boy, it bubbles and foams.
And here is a piece of rock, a sedimentary rock, that was made out of those shells.
Yeah, all the little shells
See, you
on
can see little tiny shells on it over here. Well, now, if it's true that scientists can check for calcium carbonate in the shell with the acid, how about it putting a drop on here?
We can find out.
Okay, try it. See how it bubbles too?
Yep.
So they know
Just like the shell.
that this has calcium carbonate in it. It probably came from shells. And this is a form of sedimentary rock. Now, when you had great heat and pressure put on this sedimentary rock, now it changed to what? Metamorphic. Okay, this kind of metamorphic rock could be changed into this kind. And what does that look like?
Looks like marble.
That's right, that's exactly what it is. This kind that we looked at first over here is limestone. And when limestone has heat and pressure on it, it's changed to metamorphic rock called marble.
Oh. Say, Mr. Wizard, if the animals got calcium for their shell, and then the shell went into the limestone over there, then that was changed to marble. Well, then we should be able to put the acid on, and the marble should fizz and bubble and foam.
Sounds logical, doesn't it? Well, try it.
It does.
It does. Congratulations, Mr. Johnson. You're going to be a geologist yet. And now you know that came from the bones and skeletons of little animals, right? Here's another form of metamorphic rock. See, it looks a little different.
Test it.
Oh, we'll test it and see if it once was limestone. No, it wasn't limestone. Well, but they both were metamorphic, meaning changed from some other form. Okay, now we can go back and look at our landscape again, can't we?
Yep.
You see, here was our igneous. And right here, this rock down here at one time was sedimentary. But igneous rock flowed over it, heated it up, put pressure on it, changed it to metamorphic.
Now we have metamorphic.
And we have some over there also, right? Okay, put the metamorphic up here. Now we have the three major kinds. Igneous, formed from fire, which would be this lava, basically like granite. And sedimentary, which was formed at the bottom of a lake as a sediment and then pressed into a rock. And metamorphic, the original sedimentary rock was changed with heat and pressure into something else. Now, and many times this doesn't have to be found under the ground because let's say that at one time this was all under the sea, a great big sea here. And then eruptions took place and the earth changed and moved and some of the metamorphic rock was shoved right up here. So right out here you could mine marble. And also at the same time an igneous shaft pushed itself right up to the ground and right here you could mine granite. And notice that it pushed the sedimentary rock in various ways. So now we have the three kinds, igneous, sedimentary, and metamorphic. Okay, now I have a very unusual specimen to examine. Would you help me move away this trough here? And you can also move that glass out of there. Here's the specimen right here. What do you think of that, Mr. Johnson?
A very interesting specimen. Is it igneous?
No, I wouldn't say that it was igneous, would you?
Quite.
I wouldn't think so.
Is it sediment or what?
Sedimentary?
Yeah, sedimentary.
Well, I rather doubt it, don't you?
Well, then it's metamorphic.
No, I don't even think it's metamorphic.
Well, then what is it?
Well, why don't you examine it very closely?
Well, there's some layers.
Yes.
And that means that, well, each individual layer was stuck on the other one, you know, and then they were packed together to make this rock.
Right. In fact, you can see those layers very often, when you go up a hill and they've cut away the top of the hill, and you can see the layers formed like this. Well, sometimes it takes thousands of years to just make one of those layers.
Well, how many years did it make them make this?
Well, just a few minutes, I'd say.
A few minutes? Well, see, Mr. Wizard, there's some arrows on top of here. Well, are they possible that that's fossils?
Fossils? Well, I don't think so. Fossils are the shapes of shells and animals and leaves that have been pressed down between the layers and left their form. These were made with, I'd say, a sharp instrument, so I think that etchings would be a better word.
Oh, well, were they made by human beings?
Oh, naturally.
See, Mr. Wizard, isn't it kind of funny that all the arrows are pointing one way?
Well, let's check that side over there where they're pointing.
Say, there's some writing on it. It says, open here. Well, this is a rock with its built-in instructions.
Built-in instructions. Well, are you ready to follow the instructions?
Okay.
Well, here, let's see if we can pry the layers apart. You ready?
Follow the rules of good health.
Well, you certainly know those, Mr. Johnson, don't you?
Oh, sure. If I get plenty of sleep, exercise, fresh air, water, and rest, 3 well-balanced meals a day.
Right. Are you ready to examine the next layer?
Hey.
Right.
And here's the way to get started on those rules of good health. With a good breakfast of fruit, cereal, milk, bread, and butter.
Right. That's the way to get started on those rules of good health every morning. Now, the reason for that is, Buzz, nutrition experts have found that it's very important for all of us to get from 1/4 to 1/3 of our whole day's food needs from the breakfast we eat. And they've also found that there's no better way to get them than from a breakfast, well, like this one over here, for instance. See? A breakfast of fruit, cereal, milk, bread, and butter. Or other foods for variety, like eggs or breakfast meats.
I like a breakfast like that every morning because it tastes so good.
Well, it certainly does taste good, Buzz. But in addition to that, doctors found in a series of tests on college boys and girls at a big Midwest medical school that when you've had a good cereal breakfast, like that one, for instance, you're able to work better, you're a lot keener and sharper, and your muscles won't get so tired, especially during the late morning hours.
And that's why I say it's smart to start every day with a good breakfast of
fruit, cereal, milk, bread, and butter. Right. Now, you see, sometimes geologists can make very important discoveries.
Well, we did.
Such as the one we made over here, right? In fact, you know what I made that rock out of? Remember, it was a man-made rock? I know because I made it, see? It took me just a few minutes, and I used a kind of a form of sedimentary rock called clay.
Oh.
And when clay, as a sedimentary rock, is changed to metamorphic, you know what it is?
What?
Slate.
Slate?
Slate, yeah.
You know, like the blackboards?
Like the blackboard. And they also make roofs out of it, don't they? Well, so far now, we've made several important discoveries, but we still have a little problem here, in that ordinarily when we walk on the ground, it isn't any one of these. It's sort of a black dirt, isn't it?
Oh, yeah.
Soil. What is, you suppose that is? How did that get there? What is it?
Maybe it's a form of igneous and sedimentary and
Metamorphic?
metamorphic all mixed up together.
Well, it could be, but there's a special element that's been added. See this hot plate over here? Well, I got a can cover on the top. I'm going to put a mixture of metamorphic, sedimentary, and igneous, called sand, on one side of it. What happens?
Nothing. It just gets hot.
Just gets hot. Okay, now on the other hand, on the other side of the can, I'm going to put some of this black stuff that we call dirt or soil. And you watch what happens. See?
Boy, that smokes.
It sure smokes. Does that give you any clue as to what might be the other ingredient in soil?
Burns.
It burns. What is it that you put in the fireplace and it burns? Smokes? Wood. Well, the material that's in soil that makes it different from sedimentary rocks and all the other things is organic material. That means at one time it was growing like a tree. It fell over and, when it went into the ground, it decayed and had a lot of carbon in it. That's why the dirt is black. And it's a mixture of this organic material and this sedimentary, igneous, or metamorphic rock that makes soil. And that black stuff is very important because that contains the food that plants need to grow on. And so it's usually known as topsoil because it's found on the top layer here. You see where the trees are growing? That would be known as soil. And sometimes it takes thousands of years to just make an inch of it. And sometimes it blows away with the wind, and erosion. So that would be soil. So let's put a soil sign up here. Like that.
Now we have them all.
Now we have them all. What was this?
Igneous?
Igneous, yes.
Igneous.
What does that mean?
Well, that means fire.
Came from fire.
Yeah, came from fire.
Right. And an example of that is what?
Granite.
Granite. Okay. How about this white stuff right here?
That's sedimentary.
What does that mean?
And that means, like the sedimentary.
Formed as a layer.
Yeah.
Formed as a layer, that's right. And what is a good example of that?
Limestone.
Limestone. Oh, that was formed, remember, out of the shells and the skeletons of animals, and not from igneous rock.
Yeah.
Okay, now, what is the other kind?
Metamorphic.
Very good. And what does that mean?
Well, that means change form.
Change form, right. And what's a good example of that one that you know?
Marble.
Marble, which came from limestone, right? Mm-hmm. Well, fine. And finally, you have soil, which has an important thing added to it. What is it? Organic. Organic material. In other words, it was growing at one time. And incidentally, by the way, some of that organic material could be down here in the sedimentary when it folded over and be buried down in here, and they'd later get it out as coal.
And oil, maybe.
And oil, sure. So there we have the various types. Now remember, we had a man-made one over here. Mm-hmm. Well, man actually makes a very good rock. It's a combination of sort of sedimentary and metamorphic put together, and he calls it concrete.
Oh!
In fact, I've got some concrete over here. In a special kind of tester, because it's surprising how strong man can make his own rock. Here's the concrete down here in the form of a block. And they use this machine for testing concrete to see that it will hold up under the load that is necessary, see? So here's a dial up here. And it's going to keep track of the number of pounds I put on with this hydraulic press, so you watch. You read out the number of pounds.
200,000.
How many?
200,000.
20,000.
20.
There's 30, we just passed. Now
30.
40,000. A little below 50. There, we're a little below. Now we're coming to 60,000. Almost 70. There's 80,000. 90,000. Pretty soon we're going to have 100,000 pounds. There's 100,000. There's 100. There she goes.
More.
See how much? 100. Well, it was about 130,000 pounds. And take a look at man-made rock. See why I said it was sort of like sedimentary? Because it has all these bigger rocks in it held together with a thing called cement. And there's a changes form, too, because there's a chemical reaction that takes place in it. That's why I sort of was sort of like metamorphic also. Well, now that you know all about these various kinds of rocks, I think it's about time for you to go home. And the next time you go out on a hike, see if you can guess what kind of rocks they are.
Okay. What are we going to do next week?
Well, next week, Buzz, we're going to examine science in the circus. And we're going to find out why this little man is so good at balancing. Here. You take that loop. You walk over there by the table. Like that. See this little man here? Well, he's sitting on a little bicycle. See? And he's so good at balancing that you can put him on this tightrope. Here, you step back just a little bit with you there. Fine. You can set him here on this tightrope on his little bicycle, and not only will he be able to stay on the bicycle, but he will ride. Now, there's a very important scientific principle about why that man stays on the bicycle, and next week we'll find out all about it as we examine science in the circus.
Don't forget to be with us next week for another exciting program of mystery and magic and everyday things when the Serial Institute again invites you to watch Mr. Wizard. Oh, yes, and by the way, Mr. Wizard lives in Chicago.